Wonderful people, this is what we will be looking at for grade 10 paper 2. So we're going to do question 2 and question 3. So this is exactly what we have. You can just pause and try to do this on your own. So this is exactly what we will be looking at, right? And let me just place the phone just right here so that I can prepare all the necessary tools that are required for us to work on this. So let me just flip the pages, try to prepare some space. All right. The following is what we have. So they say, let me just go up. In the diagram below, we have A, B, and E are the points on the Cartesian plane. We have the midpoint of AB, which is C. Also, F is a point such that AF equals FB. We can see by the lines that were drawn there, AF is perpendicular to FB. And in question 2.1, they say determine the length of AE. Now, let me just draw this very quickly for you. We have the Cartesian plane, and we have a diagram like this, and this is what we have, and this is what we have, this is what we have, and we are told that the angle here is 90, and this is equals to that. We have A, 1 and 3, we have F, we have the midpoint, which is C, 2 and 1, we have B, X and Y. This is the x-axis. We have E, minus 2 and minus 1. So remember, this is the y-axis. So this is what is provided to us. Now, having this, we can try and work on something. Now, in 2.1.1, they say determine the length of AE. So meaning the distance of AE. Now, in order to find the distance of AE, we must have both the coordinates of A and B. So the coordinates of A, 1 and 3, the coordinates of E, minus 2 and minus 1, because both X and Y are negative in the third quadrant. Right, so the distance of A and E is given by the square root of x2 minus x1 squared plus into y2 minus y1 squared. So you can choose whether you make this your x1, this will be your y1, this will be your x2 and your y2. It really depends on you how you want to do this. Honestly, it depends on you. Right, let's work on this. Right, what we're going to do, let me just take this a little bit from a distance. Very good. Jesus. Right, so I'm going to say my x2, it's minus 2. I have minus from the formula. My x1 is 1, this is squared. My y2 is minus 1, minus from the formula, and my y1 is 3 squared. And I will have minus 3 squared plus into minus 4 squared, which is 9 plus 16, 25, which is 5 units. Now remember, it's distance, it's always positive. So what we mean is that the distance from here to there, the distance that separates these two coordinates is 5 units. So it will take you 5 units getting there, 5 units going there. Right. Let's go to 2.1.2. calculate the gradient of AC. Now they want the gradient of AC. Now we must have both A and C. So we have A with 1 and 3, we have C with 2 and 1. The same thing transpires. We can say x2, y2, x1, y1. So I know that the gradient of AC is equals to the change in y over the change in x. Remember, the change is final minus initial, x2 minus x1. Very good. So my y2 will be 3 minus, and my y1 will be 1. My x2 will be 1 minus, my x1 will be 2. Very good. Now from here, 3 minus 1, it's 2 over minus 1, which is minus 2. And that would be the gradient. Right, the questions are easy thus far. Let's continue and see what will happen next. Right, calculate or find the coordinates of B. Now things are becoming a little bit tricky. They wanted the coordinates of B. We have the midpoint of A and B. Very important. This is the midpoint that tells us that the distance moving from here going there is the same as the distance moving here going there. Very, very important. But because we have the midpoint, we're going to use the midpoint formula. So the midpoint of AB is equals to x1 plus x2 divided by 2, y1 plus y2 divided by 2. So in other words, the midpoint of x in A and B is x1 plus x2 divided by 2, and the midpoint of y is y1 plus y2 divided by 2. Now remember, I have the midpoint. The midpoint is C with the coordinates of 2 and 1. So I have my C with the coordinates 2 and 1 as the midpoint. So the midpoint of x is 2. So I'm going to substitute 2 there. 2 equals, now let's check. Remember, we are looking for the coordinates of B. I have my A with coordinates 1 and 3. I have my B with x and 1. So you can say x1, y1. You can say x2, y2. Right, and then we're going to substitute them here. My x1 is 1. My x2 is x divided by 2. The midpoint of y is 1. So I'm going to say 1 equals, my y1 is 3 plus my y2 is y divided by 2. Now in here you can just cross multiply. 2 times 2 it's 4. 1 times this is the same as that. Cross multiply. 2 times 1, 2, 3 plus 1. Take to the other side. 3 equals x. Take to the other side. Minus 1 equals y. Let's check if this is making sense. On this side, x is positive, hence we have x of 3, and y is negative, hence we have minus 1. So we are correct in what we are saying. Remember, in the coordinates that we have found, x is 3, x is positive, this is correct, and y is minus 1, y is negative. So we are correct in this. Right, and then we go to 2.2. Some learners might struggle to find that, but if you are a student of Papa Fanzo, nothing is mysterious in this world. Right, in 2.2 they say BE. Let's check where is BE. Okay, we can see there it is, BE. They say BE is joined to form a special quadrilateral, okay, which is called AFBE. All right, name the special quadrilateral AFBE. Give full justification for your answer. So let's combine this. Right, and as you can see that this is special quadrilateral that we are having there. So what do we call this quadrilateral? If this side is equals to that side, therefore two angles are equal. Can you see this? Let me show you something. let's try to draw up a kite. We know that in a kite, this is equals to that. Can you see that this is very much similar to this? Can you see? So we can just say this is a kite. And what are the special properties of a kite? This is the question that you need to ask yourself. I'm going to leave you at that point. There are 3 marks that are provided. You need to give the special justification for your answer. Go and look at the properties of a kite, or what you can do is the following. Let's check what we have been calculating thus far. We saw that the distance of AE, which is this, is 5 units. We saw that. What do you think the distance would be here? What do you think the distance would be there? Let's check. Let's look at the distance of BE, which is equals to x2 minus x1 squared, y2 minus y1 squared. Right, I'm going to write E minus 2 minus 1, and I'm going to write B 3 and minus 1, and I'm going to use the distance formula here, x1 y1 x2 y2. Let's check what is going to transpire in here. So I will have a 3 plus 2 squared, because that will be 3 plus 2, negative times negative is positive, and then I will have minus 1 plus 1 squared. So this will be 5 squared plus 0 squared, which is the square root of 25. Can you see that it is the same, which is 5 units? So the distance here is the same as the distance there, and these are the properties of a kite. So we will say the AF is equals to BF. The reason we can say this is given, we are justifying, and we can also say that BE is equals to AE, which is equals to 5 units. And then for these reasons, because there are 3 marks for that, they will give you 1 mark for saying it's a kite, and they will give you 2 marks for justification. We saw that AF is equals to FB, which is given, and then we have proved that AE is equals to BE 5 units. There are different ways in which you can look into this. Please guys, do not restrict yourself. Please, there are many ways you can look into this. Right, I'm just going to name those few. In 2.3 they say calculate the area of triangle AFB. They are looking for the area of triangle AFB. How do I calculate that? The area of AFB. Now let us look at AFB. If we are here and we want AFB, there it is. Look, there it is, AFB. Now I can find that. Right, you see that we have one angle that is equals to 90, very important, and the side which 90-degree angle points to is the hypotenuse. You remember that? And you remember we said that the area of a triangle is equals to half base multiplied by perpendicular height. Right, what we can do from here is to find the base. So meaning we need to find the distance of AB. Very important, that would be the base, and then we need to find the perpendicular height. Now this is what we have. Now if we do this in here, this will be our perpendicular height, because it produces 2 angles of 90 degrees. Right, so meaning I can find the distance here very quickly. The distance of AB is equals to x2 minus x1 squared. That is our base, y2 minus y1 squared. Now let me write the coordinates of A and B. The coordinates of A is 1, 3. The coordinates of B it's 3 and -1. Right, so from there what I can do is to say x1 y1, so my x2 will be 3 minus 1 squared minus 1 minus 3 squared. This is what I have. And then I have 2 squared plus minus 4 squared, which is 4 plus 16, which is the square root of 20, which is 4 times 5, which is 2, the square root of 5. I will assume that you understand the square rooted numbers. So I have the base, which is AB. Now I have the base, this side. I have this side. I just need the perpendicular height. And because this cuts equally between this distance to that distance, I can divide this total distance by 2 so that I know what side this is and what side that would be. But if I do that, let's check what is going to happen here. Do I have the coordinates of F? No, I don't. So how do I go about doing this? Now let us look into this. I can have a distance on the side, but I do not have the distance here. Okay, this is problematic. And then what else can I do? Brum, 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 brum. Let's check what we can do. Let me go to the statement then. They said AF is perpendicular to FB. AF is perpendicular to FB. So that just tells me that when I multiply those two gradients, I should get a value of -1. Okay, so let me look into this. We are told that AF is perpendicular to FB. So the gradient of AF multiplied by the gradient of FB should give us -1. But what help will that do for us? Let us try to check this. And the other question is, can I find the coordinates of F? Okay, I think what we can do here, I have the gradient of AC. Okay. If I have that gradient, what use will it do for me? Let me check this. AF is equals to FB. Okay, if AF is equals to FB, right, let us try to look at something here. I have the gradient of AC. Right, if I have the gradient of AC and it's not lying on the x-axis, this is problematic. What is it that we can do then? I'm trying to figure out the simplest way of working with this. If these sides, let me show you something. Remember, we have something like this, and we have an angle of 90, and this side is equals to that side. If this is 90, therefore this is 45 and this is 45, so that the sum of the angles equals 180, because this side is equals to that side, therefore two angles are equal. So what I have there I have an angle of 45 and an angle of 45. So with that angle, I can say yes. Can you see what is happening here? Look what is happening. Remember, we did this. Okay, remember we did that, and by doing that, we have the distance here, which is 2 to the square root of 5. That is the entire distance here, which is 2 to the square root of 5. I can find the distance here and there by dividing this by 2. So I can say 2 to the square root of 5 divided by 2, which I will be left with the square root of 5. So the distance here is the square root of 5 square root of 5. So I have this, the adjacent side. I'm looking for the opposite side. Can you see that? So I'm going to use a soccer tool. So I have this side, which is the adjacent, the side that is closer to the angle. I'm looking for the opposite one. I have the adjacent, I'm looking for the opposite. So I'm going to use 10. So I'm going to say the 10 of which angle? The 10 of angle 45 is equals to opposite, which is this, divided by adjacent, which is the square root of 5. And if you cross multiply there, you will get the opposite equals square root of 5 tan 45. Let me just find the value. Let me just find the value as quickly as possible. And the value is the square root of 5, the 10 of 45, and the answer is the square root of 5. So we have the opposite as the square root of 5. This is something very important. So this side is equals to that side. This is exactly what we get. This is equals to that, because tan 45 equals opposite over adjacent, which is the square root of 5, and this is what you will find, because tan 45 is equals to 1. So I have that. So I can now calculate the area. Let me just do this. So meaning the area is equals to half base times perpendicular height. Half, what is the base? The base is 2 to the square root of 5. Remember, that would be the base. Remember, the base multiplied by perpendicular height, which is the square root of 5. So I can have 1/2, 2 times the square root of 5 times the square root of 5 is 5, which is 1/2, 10, which is 5 units squared. That would be the area, and that brings us to the end of part 3.